Let us apply the knowledge we learned in lesson 1 by doing question 1 so that we can see and measure our understanding. 1.1, they say, given that R is equals to 20. Under 1.1.1, state whether R is rational or irrational. So we are doing question 1.1, and we are under 1.1.1. Now we are given that R is equal to 20. Then they want us to assess whether R is rational or irrational. Now R is equals to 20. This means that if we study this number, we can see that this number falls under the natural numbers or under the whole numbers. And we know that natural numbers and whole numbers are integers. We can further write this number as 20 over 1, which has the form of A over B, where A and B are integers. I mean, both the 20 and the 1 are integers. And definitely the 1 there is not a 0, right? So without a doubt, this number has to be a rational number. And this will be marked 1 mark to be able to do that. Remember that with the marking system that we use in high school is that you spend 1 minute for 1 mark. So all this knowledge here or answering this question shouldn't take you more than a minute. And in fact, when you practice enough, when you already are experienced, you can do them in less than a minute. We will then move to 1.2. That says that given that x is equals to the root of 9, so we are in 1.2 and we are told that x is equals to the root of 9 and y is equals to the root of 7. Y is equals to the root of 7. The question says here that classify if x or y is an integer. So I'll start by doing 1.2.1. That says that we should classify if x or y is an integer. Right, so between these two, x and y, which one is an integer? If you look at x, maybe let me remove this numbering a little bit. If you look at x, you can see that it can be written as 3 to the power 2, so that the root sign we know from grade 9 that we can write it as 1 over 2 as an exponent of 1 over 2. And these two will multiply each other. You know, you should remember these things from your grade 9. When they multiply each other, we can see that these two and these two would cancel, so that we are only left with a 3. So this one required us to work a little bit on it before we can answer this question. So this is to say here that our x is equals to a 3. Now, if you don't remember this information here, this will serve as a revision, or you are allowed to use your calculator. And there's nothing much we can do with this one. It really ends there. We cannot simplify it any further. Now, to answer the question 1.2.1, we can clearly see that between this number and this number, x has to be an integer because it falls within a list of integers. Remember in lesson 1, we were writing them in a set form within a sets within the curly brackets, right? So the answer for this one here would be x, because x is an integer, right? This is for 1 mark. Just for writing that, you will get 1 mark. Now we go to 1.2.2. It says classify if x or y is irrational. Already we know that y must be rational because we found x. But let's see if it's irrational. Remember that irrational numbers are the numbers that cannot be written in fraction form. You know, a number like this, you cannot write it in fraction form, right? And when it's a decimal, it is non-terminating and non-recurring. You know, if you press this number on a calculator, you'll see that it is non-recurring, it is non-terminating. So the answer here is Y. You need to know that information in order to answer these questions. So if you don't know that information, go to lesson 1 and be sure that you thoroughly understand the information in lesson 1. So again, this will be 1 mark. Right, then we go to 1.3. 1.3 says that suppose that t is equals to m over n. One point three, they say t is equals to m over n, right? Where m is equals to 0 and n is equals to is not equals to 0. So we're saying here m is 0, right? And n, it should not be 0, right? And at the same time, n can be an element of rational numbers, right? N can be an element of a rational number. So now what's going on here? If we take this m and put it here as a 0, because we are told that m is a 0, right? It means we are going to have a 0 over n, right? And we're saying that n should never be a 0, because if we put a 0 here, this whole thing will be undefined. But n is allowed to be any of the rational numbers. Remember that the rational numbers can actually be written in the form of a over b, right? Where a and b are integers, but b should not be equals to 0. So if we put any fraction here, if we put n can be any fraction a over b, it can be 1 over 2, it can be negative 3 over 5, it can be 7 over 10, it can be any fraction, right? We divide by that here, right? But you'll realize that it doesn't matter if we divide by any rational number. This whole thing will be a 0, because 0 divided by any number is a 0, right? Now, to answer this question, they say to us, is t a natural or a whole number, right? Is t a natural or whole number? If we look at t, we just discovered that t here is equals to 0, right? So is this number here natural or whole number? Definitely this is a whole number. Remember that whole numbers include the natural numbers and 0, right? So it cannot be a natural number, because the natural numbers, they begin at 1 and they grow until infinity, right? So this again is going to be 1 mark. Then we go to 1.4. So 1.4 requires us to actually put symbols. They say write down the correct symbol for each of the following. They've given us 1.4.1 up to 1.4.6. Let me do the numbering so that we can answer this one very quickly. 1.1, 1.1, 1.4.1.2, 0.3, 0.4, 5, and a 6. So what is the symbol for a natural number, right? We know that the symbol for a natural number is actually a capital letter N, like that, right? What is the symbol for a whole number? It is similar to that of a natural number, but it has a subscript 0 at the bottom to say we begin our numbers at 0, right? Then 1.4.3, they say integer. Integers are represented by a symbol of a Z, like that. And they then ask us 1.4.4, rational numbers are represented by a Q, right? That is a line like that. And then irrational numbers, same symbol, a similar symbol as rational numbers, but there's a dash there at the top, right? So we pronounce it Q prime. Then we have real numbers. Real numbers are indeed represented by an R that has a line like that, right? These are simple things that you can memorize. They are there in lesson 1. You just need to memorize them, have them in your fingertips at any time to answer these questions. We will then do, and all of this, labeling all of this, or rather, putting a symbol for all of this will guarantee you 1 mark for each of them, right? Again, 1 mark, 1 minute, and really this you can spend less than a minute answering each of them, right? So this means if you are doing a question paper, this is where you save time. But of course, you will save time if you studied. Then we have 1.5. That says consider the following numbers, right? So they give us here 1.5. They give us here the root, not the root, but actually the third root, right? The third root of -8. And they give us a number here called pi. We talked about this one. They give us 3 plus a root of -5. So they've given us these 3 numbers. They then say to us, which one of the above numbers, right? Which one of the above numbers under 1.5.1 is a real number, right? Is a real number. Which one is a real number here? Right, if we look at these numbers, we can see that actually let me use this space here at the top. The third root of 8 can be, simplified. We can do something about it before we can answer this question. We can actually take this number like this and say it is the same as -2 to the power 3. Remember that if you multiply 2 3 times, it will give you -8. So if you say -2 times -2 times -2, you'll get a -8, right? So we can write this number here as a -2 to the power 3. But we know again from grade 9 that a cube root, right? The cube root of -8, the cube root can be written as 1/3, right? Then at this stage, you can apply one of the rules of the exponents that we know from grade 9 to say these two will multiply each other. And when they multiply each other, the 3 and the 3 will cancel. Because remember, these 3 will sit at the top here. It will be 3/3. And then when they cancel, you will only left with a -2. Because those 2 will, when they cancel, they'll give you a 1 here, which will write as an invisible 1 like that. So it's a -2, your answer. So I'm saying here that this number here is the same as -2. Now let's look at the first question. Says real number. If you look at this -2 is an integer, and we know that an integer is a real number. So -2 will indeed be a real number, right? It will be, so they're not saying a real number, they're actually saying a real rational number, right? So a rational number, yes. So 2 will be a rational number, right? Because it's an integer, and integers are rational numbers. And remember that we can write this as a fraction to be -2/1, which is a over b, where a and b are element of integers. These 2 are integers, right? So 2 is a rational number. Then we have 5.1.2. They say a non-real number. obviously when you look at this number here, you can see that it's a non-real number because it has a real number component, right, and an imaginary number component. And we said a real number and an imaginary number, they together form what we call a non-real number, right? So this number 3 plus square root of 5, it's actually a non-real number. Then obviously the last one has to be pi, but I mean we spoke about it because here we want to get a real irrational number, the one that is an irrational number. Pi we said is an irrational number because we spoke about this extensively to say a pi it can be written, it cannot be written as a fraction, right? It cannot be written as a fraction or a ratio. It cannot be written as a rational number, right? And also in decimal form, it has decimal numbers that are non-terminating, that do not stop. They become lengthy, those decimal numbers. They just always give you numbers. And those numbers that you get after the decimal point, they are actually non-recurring. They don't have a repeating pattern. They are just a random numbers that are forever going like that. So pi would be a real irrational number, right? And very important here, just to entertain the word real. They're using the word real because we said the rational numbers and irrational numbers together form real numbers. And of course, the complex numbers, right, are non-real, right? Also, the imaginary numbers are non-real. Now, each of these questions, they are marked at 1 mark. So it means you should spend 3 minutes or less, right? 3 minutes at the most. You'll get 1 mark for each of them. And this question would give you a total of 13 marks if you do the whole question.